phase difference between E and B or E and H of the electromagnetic wave, the electric field and the magnetic field, or the electric field and the magnetizing field. We know that the EM wave is a transverse wave. It means that E and B both are mutually perpendicular to each other. EM wave is transverse wave. Near the source of EM wave, the phase difference between E and B is 90 degree or pi by 2 radian. It means that this phase difference delta phi is equal to 90 degree or pi by 2 radian. This is just at the source of the EM wave. The phase difference between the E and B depends upon the distance from the source. So as the wave goes away from the source, the phase difference decreases. The phase difference between A and B decreases when EM wave goes away from the source. So this is what that this delta phi is proportional to 1 upon r. This is like this. So when this r equal to infinity, that r tends to infinity, then the delta phi tends to 0. At r equal to infinity, delta phi equal to 0 degree. The source of EM wave makes electric field to change sinusoidally. It means what? That this E is equal to E naught sin omega t minus kx. Kx minus omega t. This varying electric field instantaneously produces magnetic field. Varying sinusoidally with phase delay. So now phase delay is pi by 2. Phase delay of pi by 2 radian. It means that this B is equal to B naught sin kx minus omega t minus pi by 2. So this E is the driver of B, or we can say that the electric field drives the magnetic field. The electric field drives the magnetic field. Or E leads B by pi by 2 radian. This is what the phase difference between E and B or E and H. Power density of EM wave. This P is equal to this is the power density. where epsilon naught is the electric permittivity of free space. Mu naught magnetic permeability of free space, F frequency, E this electric field, H the magnetizing field, S the surface area. S is the surface area. This gives the power flow per unit area. So this is the formula for the power density. This is also called the power density. So whenever we say the power density of the electromagnetic wave, it means that the power flow per unit area of the electromagnetic wave, that is called the power density. For linearly polarized light, the phase difference delta phi, this is equal to 0 degree. So now what is there, that the electric and magnetic field both oscillate in the same phase, though they are mutually perpendicular to each other. The A and B are mutually perpendicular, but they oscillate in same phase. तो इनकी डायरेक्शन म्यूचुअली परपेंडिकुलर होती है, लेकिन इनके फेज एक जैसे होते हैं. तो सेम फेज में होते हैं. जब एक की वैल्यू मैक्सिमम होती है तो दूसरे की उसी तरीके से वेरी करती है. सो दैट वी कैन से दैट दिस इज नाउ, सपोज this we take x axis, this is y axis, this is now z axis. Here we take the electric field, here we take the magnetic field in this direction. This is now origin, and then we can have the wave. This is magnetic field, sorry, electric field, and this is the like this. So this is for E and this is for B. This is now wave. That wave propagates in the x direction. So all are the mutually perpendicular, the electric field, magnetic field and the wave. So we can have that the phase difference between E and V is 90 degree near the source of the EM wave. But as the wave goes away from the source, this phase difference decreases. At infinity the phase difference is 0. And for linearly polarized light, the phase difference between the A and B is equal to 0, and also we can have that E and B are mutually perpendicular but they oscillate in the same phase. So this is about the phase difference between the E and B. So whenever the question is asked that what is the phase difference between E and B or E and H of the electromagnetic wave, then this is a 90 degree. Always remember that this is given 90 degree. If suppose we are having the conducting medium, then phase difference is somewhat different from this one. Moves in good conducting medium. The phase difference between E and B is 45 degree. It means that this delta phi is equal to 45 degree or pi by 4 radian. So thus the phase difference between different medium is different, but when the source is in free space, and then the phase difference between E and B is always 90 degree. So this is about the phase difference between E and B or E and H, and so many times the question is asked that what will be the phase difference between E and B of the electromagnetic wave or E and H of the electromagnetic wave. So that you can answer it from this topic. So thank you very much.